structure, I mean that we have to create first a metallized signal, that is our ground reference, as a first layer. The second layer is a dielectric material that normally we use as board. And the first layer
Primero el metal.
is the signal layer.
No, aquí. Aplasta aquí. De metal. ¿Y con qué nombre está?
Yeah. Remember that the signal is a Cooper.
The electric.
The dielectric we have to change to
¿Cómo voy a poner
Parte1.
Es que es de metal. Este señor está haciendo rápido.
And the activate layer is a signal layer. Once we determine the layers, we need to create
Eso es
patch
Add layer.
with the
Ahí ve el dieléctrico.
tools that we
Segundo,
have.
tipo. Dieléctrico, el de arriba.
This is the patch.
Este no sé qué nombre está.
Then remember that we use here not second point description. We don't use second point description.
El
We
double.
use
El
the
debe ser
center
double.
point that normally we put in the center of the system, and we have the width and height. Now this is very important what we will explain now, because normally, as you see in the last class, we have to change the size of the patch. And to do directly that, we need to use variables. How we insert variables here? Instead to put directly a size, we put a dollar and a variable. For example, we can say here $L. Then in this moment we have created a variable. Then to create a variable in Ansoft Designer,
No sé, la
we
señal no es esa.
dollar with the
Borra
name
eso,
of the
no sé.
variable. In this case I put
Ahorita estamos con el
L
dieléctrico. Primero es el
If I
dieléctrico.
continue directly,
Ya, con cualquier
the
nombre.
software inquire me the size. In this case, I let it 28
Ahí van otra vez
millimeters.
al layer. Ahí sí toca la
Because it's a
señal.
square,
Ya,
I
eso
put
le pongo
once
una S y
again
pongo
in the
OK.
head of the patch this $L,
Aceptar. Ahí
okay?
vamos al cuadrito de aquí.
And you
Ahí es
see
el cuadro que está haciendo.
immediately the size is exactly the same, 28, 28. Okay?
Ya está. Eso es el
Then
cuadro.
as you see here,
Ya.
the patch is centered in the system. I mean, this point
Dos
is the
puntos.
point
Doble
0,
clic.
0. This is the width, and this is the height. Okay? In this moment, it's 28 millimeters. It doesn't matter because we are going to change. Okay? Then, before to continue there, we have to do the first type of antenna to determine exactly the size of the antenna.
Es
Okay?
que se va a determinar.
Then, as you remember, we can use the calculator, okay, to determine the size of the antenna. We need to use a square patch. Frequency, I don't know, we can use the same as we used 3 gigahertz in the last class. Input impedance 50 ohms, and voltage standing wave radio. We put 2 because it's the minimum value. And here we have the dimensions. As you remember, in the last class, the dimension was 23.4 millimeters, and the offset, horizontal offset, is 9.2 millimeters. Okay? Be ready in case my computer doesn't work. We can use your computer. You will continue doing. Okay? That's nice. Then we have to change first here in project variables. Here we have the variable that we created before with 28 millimeters. But here in the calculator it says that it's 23.5. If I don't make a mistake, we put near to 23 millimeters in the last class. Then we change to this value, you can see we are antenna is smaller, and as we did in the last lesson, we put the coaxial cable directly, this via. In the left side, in the model, you have this via, and you put as properties, you go to the lower layer, and you make the feed as a coaxial excitation. Once done it, we need to change the position of the port in the properties. Sorry, it's in the via. In the footprint. Okay. You remember the position? I don't remember, I guess it was 28 millimeters. Okay. We have to do the analysis. The analysis was in 3 gigahertz. And we need to define a sweep. We use from 2.8 until 3.2 because remember that the central frequency is 3 gigahertz with 21 frequencies. We use interpolating simulation and we just do. Once it's finished, we create the results. Remember that the results are the S parameters as the first result, and the second result is the impedance as a real and imaginary part. Then as you can see here, the imaginary part is near to 0 and the real part is bigger than 50 ohms. Okay? Then because the impedance, the real part is bigger than 50 ohms, we need to go to the center of the antenna. Because remember that in the center of the antenna we have 0 as an impedance. It's a short circuit. Okay? Then we need to change. Let me put the position of the feed as a variable too.